Welcome everyone to the Rotating Magnetic Field Thruster. My name's Tate, and if you'll let me, I'll take you on a little tour of this technology today. Now you may ask, why electric propulsion in general? Well, the primary benefit of EP is the divorce of propellant and power supply. Where conventional chemical propulsion requires lots of propellant to achieve a given power level, electric propulsion with its external electrical power can provide energy to a much smaller amount of propellant. However, a necessary trade-off is that this increase in fuel efficiency comes at the expense of thrust. But for in-space propulsion, this isn't a major concern, and lower propellant demands results in lighter spacecraft and lower launch costs. Now the operation of an RMF thruster proceeds as follows. An initial seed plasma is injected into the thruster, usually with a low ionization fraction, and can be provided by a cathode or an RF source. Then, the magnetic antennae are fired, with tightly controlled phasing to generate the rotating magnetic field, which completely ionizes the propellant. The carefully chosen RMF frequency then selectively entrains the electrons and leaves the ions demagnetized due to their higher mass. The new circular electron current generates a Lorentz force on the plasma slug by an interaction with a steady diverging magnetic field, and the plasma slug is ejected. One might ask at this point, what are the advantages of the RMF thruster? Well, due to the independence of plasma source and the magnetic confinement of the plasma, the thruster can achieve low wear and therefore long lifetimes and can use a wide range of propellants. Second, the RMF thruster is also highly throttleable, because the average thrust is determined by the pulse rate, and a single pulse can be optimized for high efficiency across many thrust levels. This allows for a multi-mode operation, trading between a high thrust and low specific impulse mode, and a low thrust and high specific impulse mode. Finally, compared to other inductive thrusters, which share these previous advantages, the RMF thruster decouples the antenna current from the driven plasma current, thereby allowing higher performance with lower demands put on the drive circuitry. As a final note, this technology is still in the very early stages of development, and there are some obstacles to be overcome by the group at pepl in particular. First, we need to demonstrate the performance of our RMF thruster as intended. We then need to find ways of optimizing the energy transfer between the RMF and the propellant plasma. Part of this includes controlling the trajectory of the neutral propellant and seed plasma within the thruster so that it is better entrained by the RMF. Well, I hope my little talk has convinced you to at least keep an eye out for the future advancement of RMF thruster technology. As always, I'm Tate, and remember, if it's rotating, it's worth graduating.